You can summarize Kirchoff's voltage law, or KVL, by saying that if you sum all the voltages in any kind of a closed path in a circuit, that should be equal to 0. So if we want to solve, for example, for Vx and Vy in the circuit right here by using KVL, the first question to possibly ask yourself is how many closed paths are there in this circuit? Well, there's the obvious 3 that are right here. We're just kind of looking for rectangular shaped paths in the circuit. But there are also more than that. There's one around the perimeter. There's kind of less intuitive ones by this kind of manner, going off around the 6 volts, kind of skipping around. Also stuff like this, maybe skipping over this unknown resistor right here. But at any rate, we're going to use that to solve for Vx and Vy. So to start off, let's solve for Vy first, because it seems like it's the most intuitive thing to solve for first, because of how easy it is to see the KVL path for it. So right here, if we do KVL, I'll start right here and go clockwise. KVL. And just real quick, there's 2 different ways to teach how to do KVL. Some will tell you to write the first polarity sign that you see in your equation. Some tell you to use the second sign that you see. I'm going to use the second sign because it kind of makes more sense later on when you look at nodes and such. Okay. So our first term is going to be negative Vy plus 4, then minus 6 is equal to 0. So then Vy is going to be negative 2 volts. Okay, so for Vx, we'll do a KVL path around the perimeter. So basically, we're skipping over the voltages of this unknown voltage across this resistor, this 4 volts, and the 6 volts right here. So KVL. We'll start again right here and go clockwise. So our first term is going to be plus Vx. So Vx minus Vy, and then plus 12 is equal to 0 because we're back where we started. So from this, Vx is going to be equal to negative 14 volts. And that's the basics of how to set up a KVL equation. If this video helped you out in any kind of way, be sure to give it a thumbs up. See you around.